Okay, in this problem we've been asked to solve the following trigonometric equation. The most common mistake, and the one that you absolutely have to avoid, is to divide both sides by cotangent x. You see, if you did that, this would go away and this would go away, and you'd end up with cosine squared of x is equal to 2. And we're going to see in a little bit that's going to yield a no solution answer. But there are solutions to this problem. And the fact that you divided the cotangent out is what happened, is why we got rid of the real answers to this problem. Okay, so we cannot divide cotangent out in this situation. Instead, what we have to do is we have to subtract the two cotangent x from both sides, so we can set it equal to 0 first. Cotangent x cosine squared x minus 2 cotangent x is equal to 0, right? Subtract it over to the left. The reason that I do this is because now I notice that the cotangent is in both the first and the second terms. That means I can pull it out. And if I pull that out, then I notice I'm left with, on the inside, cosine squared of x, and then minus 2 for the second term. So this really tells me I have two solutions. Either, from this one, cotangent x is equal to 0, or cosine squared of x minus 2 is equal to 0, which means that cosine squared of x is equal to 2, which means that the cosine of x is equal to plus or minus the square root of 2. So how do I solve these problems from here? Now I've gotten to this point where I've got cosine by itself and I've got cotangent by itself. We might recall, by the way, that cotangent is the reciprocal of sine. So if I wanted to call cotangent 0 over 1, perhaps, that would be 0, right? That means that tangent of x would be 1 over 0. Okay? Cotangent x is equal to 1 over 0. Well, this only occurs at one spot, and that happens to be at 90 degrees. Or 270, I guess. Right? Now I can check this when I end up with undefined and weird things like that. If I wanted to check, notice my calculator is in degrees, and I could do, okay, tangent of 90, undefined, right? Can't do it. Tangent of 270, also undefined. Can't do it. So, that's one way to do it. Another way to do this thing, I know my two solutions here. X can be 90 degrees and 270 degrees. Here's another possible way to look at this problem. If I was just going to graph then, y is equal to the tangent of x, or, you know what, even better, let's say you didn't know this thing. Let's say you didn't know to flip it. I could do 1 divided by tangent x. Whoops. 1 divided by tangent x. Okay, and I'm interested in where this thing is 0. I just graphed cotangent, right? Window here, let's go from 0 to 360. Let's go 30-degree increments. Y values, let's just go from -4 to 4. We don't need much for the y value, right? When I graph this, here comes the cotangent function. I see that it's 30 in two different locations. Those two locations, I remember my tick marks I said would be 30. 30, 60, 90, and 270. So there's another way to do this. You can use your grapher. Alright, for the other one. Cosine of x is equal to plus or minus square root of 2. So for this one, it's not just a weird value. For this, I could actually use if I wanted to. Let's start with the positive one. Let's don't worry about the negative square root of 2 yet. If I do the arc cosine of square root of 2, I get an error. And then I start to realize, wait a second, cosine is limited to plus or minus 1. And this is 1.4. Square root of 2 is 1.4. So it turns out there are no solutions there. And see, if you would have divided out the cotangent at the beginning, you would have ended up with no solution. We would have lost the 90 and the 270. So our two answers for this are 90 and 270 degrees, but the instructions say solve, which means two things we've discussed in prior videos. That means 1, we have to answer in radians, and 2, we have to account for infinite solutions. So if I were to draw then on these axes, if I was going to draw a 90-degree mark, it would be right here, and the 270 would be down here. They're straight across from each other, aren't they? So that means I can combine these two into one answer, and I can say that x is equal to 90 degrees, which is pi over 2. And because they're straight across from each other, I notice that they go up in multiples of 180 degrees or pi. There's the solution to this problem. And let's try the same thing over here. It's going to be very tempting whenever you work this problem to divide out a sine of x, but that's not the way you do it. The first thing you have to do is move everything to the one side of the equation and set it equal to 0. When I do that, now I can factor out. I notice they have at least one sine of x in the middle, right? So I'm going to factor out a sine of x, and that's left me now with sine of x minus 2 is equal to 0. So I have two ways to solve this. Either sine of x can be 0, that comes from this one, or sine of x minus 2 equals 0. That is to say, the sine of x equals 2. Well, remembering that sine can't be greater than 1, that means that this is no solution. And once again, if you would have divided out a sine of x, you would have been left with this 2 on the right, and you would have been left with just sine on the left. It would have been sine x equals 2, and you would have said no solution to this problem. You would have totally missed this. So the question is, when is the sine of x equal to 0? So what I can do on this problem, now here, let me pull out another trick for you, is the fact that this corresponds to the y-coordinate on the unit circle. This is, I think, an easier way to do these problems, and I haven't introduced this. I've done this in class, but not on the videos. If I was to draw a unit circle, I'm looking for all locations that have a y-coordinate of 1, and that's going to be this location here, that's a height of 1, or this location here. That is 0 degrees and 180 degrees. I know now that the sine of 0 is 0, and the sine of 180 is also 0. Of course, you could have gone through here and done this as well, right? Sine of x, where is that equal to? Is 0. And you're going to see that it happens in two locations, 0 and 180. But notice it also happens at 360, right? We've got to talk, and that's the infinite solutions that we've been discussing. So I have two solutions, 0 and 180. I notice they are a flat line apart from each other. It forms a flat line. That means that it repeats itself every pi or 180 degrees. So my solution is x is equal to 0 plus some multiple of pi, some multiple of 180 degrees. But you know what? There's no reason to write this 0 down. That seems redundant, right? So we're just going to list it as x is equal to n pi, and that's as good as it gets.